Hi, I'm here to set you up for the brain dump on the formula side. We're going to start up at the top by making our triangles. So as I make mine, if you will make yours. The top, if one way we remember this is my daily vitamin. And then we will go down to the next one and do stop talking. And then the next one, feed my animals. And the last triangle that we will draw, work for donuts. Quick, easy ways to remember. Now going back up at the top, I want to reference the idea of what these are measured in. Density is grams per milliliter. Mass can be in grams or kilograms. Volume is usually G per cm cubed. And so if you see any of these, you know what it's referencing. So that's why I like you to know them. Total distance, we could be in miles, we could be in kilometers, or we could be in meters. Total time, hours, minutes, or even seconds. And then when we talk about average speed, we could be talking about miles per hour or meters per second. And then net force, we know net force to represent newtons, which is our F. And then we have our mass, which is again grams or kilograms. Acceleration is meters per second squared. And then down at the bottom, work is in joules, the J. Force is in newtons. And then distance, meters per kilometer. All right, then we have down at this bottom, we're going to break this off into 6 different boxes, and each one we will fill in with material. So the first one, let's focus on the 28-day cycle of our moon. I like to create a nice quick little clock, and we draw the sun just so that we know where it's at. And on the sun side, we always start with new moon, and then up at the, because we go counterclockwise, we are going to go to first quarter. Then all the way across from new moon is our full moon. Across from first quarter is third quarter. Now we can fill in our little ones. So we have a waxing crescent. We have, and you can put a little X there if it makes it understandable. You have a waxing gibbous. And then after the full moon, you have a waning gibbous. And then at the third quarter, a waning crescent. And this is just a very quick way to recall that information on that 28-day cycle. And I'm going to just briefly move it upwards so that I can see the rest of my box. As you remember that we wax on, we wane off. Sorry about the light part. And then we're going to be ready to move to this box. If we start with our neap tides are 90 degrees. And even though 90 degrees starts with an N, we don't spell it out. It's just something you can remember. First and third quarter moons is when we have neap tides. And then we've got our spring tides. That's when we have straight line between the earth, moon, and sun. Straight line. And we have spring tides during new and full moons. And then I'm ready to go to the third box. Over here, we're going to focus our attention on the HR diagram. There may not be very many questions, but it is something that you want to remember. Okay, so like opposite of normal graphs, as we go out, we're going to get cooler. This spot over here where 0, 0 would normally be, this is the hottest spot. And then up here, this is measuring luminosity. Luminosity, which means brightness. And so as it gets higher, it is brighter. Our sun is right there in the middle of its main sequence. So it's not too bright, not too hot. It's just right there in the middle. And then we are also going to draw a food pyramid here, or an energy pyramid that it could be referenced. We start with our producers. They make their own food. And then we have our primary consumers. And then we have our secondary consumers. And then the top one that we will stop at is tertiary. Tertiary. Now we could go quaternary and everything else, but just for basic understanding, this is perfect for us. All right, now dropping down to the other ones, if you will bear with me with the camera, I'm going to just change the view of it. I don't want to take too much of your view away. All right, so in this box, we are going to create a circle and label it as an animal cell. Animal cells are round, whereas our plant cells are more square or rectangular, to be more specific. And then we also want to remember that animals can become mad. So as tragedy hits or things change, they can either migrate, they can adapt, or they possibly could die. This next one, we're going to focus in on Newton's laws. All right, law number 1 is the law of inertia. Something in motion stays in motion, something at rest stays at rest unless acted on by an outside force. Law 2 is F equals ma. It's also the law of acceleration. And then we have law 3, which is action, reaction. All right, we're going to pop over this last one, and this is where we're going to do tectonic plates. So if you recognize that convergent boundaries are going to collide, they go towards each other, and they create mountains. And then we have divergent. Divergent divide apart. So they pull away from each other, and they create mid-ocean ridges, and they create rift valleys. Next, we're going to talk about the transform boundary. Transform. This is where they slide past each other at fault lines, creating earthquakes. San Andreas Fault is the well-known one that usually comes up on your testing. And then the last thing I want you to remember is subduction. Subduction is a convergent boundary, so they do go towards each other, but one is going to go underneath because it is more dense than the other plate. If it is an oceanic versus a continental plate, the oceanic plate will subduct. So ocean plates will go underneath. And that is what will help you pass the STAAR If you memorize as much of this as possible, you will do amazing.